Hey guys, we're going to look at part 2 of my Geometry Common Core review guide. And like I said with part 1, if you're not one of my students, you can buy this review guide on Teachers Pay Teachers. So this part 2 is going to focus on um, sections 4, 5, 6, and 8. I'm not going to be able to do 7, unfortunately, because, well, it's kind of impossible to use a compass and straight edge on the smartboard currently. So that one you'll have to kind of fend for yourself, but we're going to focus on 4, 5, 6, and 8. So you can go ahead and go to page 11. So I'm on page 11 now, and we're going to talk about some of the angle relationships we're going to see with parallel lines. Vertical angles we talked about a little bit with proofs in class. Vertical angles are two angles that are opposite, like I'm drawing right here. Those angles are congruent, so if one was 60, the other would be 60. The other thing, linear pairs, two angles that would add up to 180. And supplementary angles, so like, let's say, for example, this angle right here was 60 degrees. Because they share a line, that would mean the angle next to it that borders that line would be 120 to get 180 total. You'll see several angle relationships with the parallels and transversals. So corresponding angles are angles that are in the same position, but touch different parallel lines. If we got alternate interior angles, it's kind of like how they sound. They're on alternate sides of the transversal. And they're both in between the two parallel lines. Opposite of that, alternate exterior. So like angle 2 and angle 5. Similar to alternate interior, just on the outer parts. And then also we got same side interior, same side exterior. And you can clearly mark those in the picture so you have an idea what you're looking at. So most of the real tricks with the angle questions is just make sure you label any measurements you have. Try to find any intermediate measurements as you go through. So we're going to look at one of the tougher ones. We're going to skip over some of these other ones right now. So like we're going to look at part of question 7. So it says right here, if angle 5 is 137, okay? So if I have 137 for angle 5, well, I can use my idea for vertical angles. So I can mark 7 as 137 also. And this is what you want to do. You want to try to label as much as you can. If I go with the whole alternate interior angles, well, 5 and 3 would be alternate interior angles. So 3 is also going to be 137. And then vertical angles again, or corresponding angles, 2 would be 137 as well. Now that's going to mean for 1, 4, 6, and 8, those are going to be 180 minus 137. So all those angles, like angle 1, for example, this one, will be 43 degrees. So I'm just kind of going through and I'm labeling. This is what you want to do with these types of questions. You want to label it. You want to know or have a reason for why you're picking the measurement that you're picking. And always go back and look at the angle relationships and just kind of work your way there. You might not find the angle you want right away. It may take a couple intermediate steps to get there, but once you get the idea and get in the habit of labeling, it's going to make these questions a lot easier. So we're going to move on to triangles. The biggest thing with triangles is the 180 degrees. All three angles always add up to 180 degrees. Sometimes they like to use classifications. But again, like I've talked about before with a lot of the geometry questions, if it's talking about something with measurements, you want to make sure you label it, or if you don't have a picture, you want to make sure you draw the picture. So you can kind of read through the classifications. We're going to look at just question 1 right now. And it says triangle ABC has angle C is 45 and angle A is 45, and then they want us to correctly classify it. So I don't see a picture. I'm going to draw one in. I'm going to label it with the letters A, B, and C. And I'm going to label the angles C is 45, A is 45, Well, all three have to equal 180, so 45 and 45 is 90, and then 90 more will make 180. So now they're going through classifications: isosceles, acute, and right triangle. So if I look at the definitions above, isosceles, two lengths the same. Well, if I have two angles the same, then I have two sides opposite that will be the same. So that's true. And since A is right, well, I might as well check C. I don't have to worry about B right now. C, a right triangle. Well, right triangle, 190-degree angle, and there you go. So in this case, this answer is going to be D. So again, kind of like I was talking about before, if you look at the back of the page we're currently on, or the next page, depending on where you are in your booklet, you know, you have one like question 11, for example. You know, we got a 90-degree angle here. You label another 90-degree angle here, and then you got 2290, and then this angle 1 will be 180. And then the same thing to find angle 2. You got a 90 here, 90 degree here, 39 here. Well, 90, 39, and angle 2 are going to give you 180. So, again, carefully labeling is going to be the biggest help when solving, or when you are solving these questions. So, we're going to move on to parallelograms. And what you're going to see at the top is you're going to see on the first page, you're going to see all the properties with parallelograms, rectangles, rhombus, square. Okay. And you can use those properties to help you answer the questions. So like if we talk about question 1 here, what is not a characteristic of all parallelograms? Well, consecutive angles supplementary, opposite angles congruent, diagonals perpendicular, diagonals bisect each other. Well, you just pretty much want to go back up and look at the list. So we got diagonals bisect each other, opposite angles congruent, we have consecutive angles are supplementary. Well, diagonals are not perpendicular. That would only be true with these two shapes right here, which are a rhombus and square. I'm just kind of using some abbreviation here to save time. So rhombus and square. So as you answer it, think about what shapes it may or may not work with. And write little notes to yourself. It's going to help with the property questions. Now you're going to see some of the similar stuff that we just talked about. So like if you look at 5A here, we have a parallelogram. They're telling you what the shape is. So as soon as they tell you what that shape is, each of those properties apply. So you can label measurements based on what those properties are. So like in this case, we talked about opposite angles being congruent. So I have 68 here, which would mean that 2 is going to be 68 degrees as well. So use those properties to help you find answers with the parallelogram sections. Okay. So we have one more section we're going to look at. And again, if you want to work on that question, finish it up, pause the video now, and after that we're going to, like I said, we got to skip over the construction section. So you don't have the construction tools, but we're going to look at dilations. So for dilations, some of the most important properties that they try to hit you with in the Regents, I think one of the biggest ones is this idea that corresponding sides are parallel. You're going to use a lot of proportions. So you're going to see a lot of, or you're going to have to set up something like this, 2 fractions, double fractions, and that would be a true proportion. So if I had 2 measurements of 2 and 4, I would have measurements of 3 and 6 if the second object was bigger and being dilated. So, and when we talk about dilations, the biggest thing is that they're being multiplied to get new answers. So you're multiplying each of the x and y values. Okay, and dilations are also non-isometric because you change the size of the figure. So let's look at one other dilation question together. So we're going to look at 5. It's a multiple choice. So they have O as a center of dilation. So here's our center of dilation right here. And they're asking us what scale factor would best suit the diagram. So when you're trying to determine a scale factor, what you want to think about is from the pre-image. So A would be considered a pre-image. It's the starting point. And then A prime is considered the image. And that would be your final point after some sort of transformation was completed. Now, as I look at this, I notice that, okay, OA. I realize that O and A is here, and then what happens is that A prime, the length from O and A to O and A prime gets smaller, which in that case it means it's going to be less than 1 for a dilation. So it's going to be more of a reduction than an enlargement. So I know for a fact right now it's not going to be D, and it's not going to be 2 because it didn't get farther away. And it looks like it's about halfway, so B is going to be a safe answer in this case. Now, if it was an enlargement, I'm just going to draw an example. Let's say O is my center of dilation, and I had C here, and then all of a sudden I had C prime up here. Well, based on distances, I'm going to assume that the scale factor of this would probably be somewhere in the neighborhood of the scale factor would probably be in somewhere in the neighborhood of 3. Okay, so you want to make sure you keep the enlargement and reduction same, and then you want to make sure at the same time that you do start with your pre-image and then think about how it moves to get to the image, which would have the prime with it. So if you have any other questions, please ask me in class, and good luck with the review.